2 lines of charge. So for the purpose of this lab was to produce a computational model of 2 charge tapes exerting electrical force on each other, and using this model to estimate the amount of charge on each tape necessary to float one above the other. Some physics concepts that we used were Newton's second law, Newton's third law, electrical field of a point charge, electrical force, and the law of superposition. This is supposed to be a for every action instead of or. Apologies. So the results of this lab were that in lab 1 we found that the Q, or the charge, was around 1.51 times 10 to the negative 8 coulombs for the tape. However, in the updated model, in order for force of gravity and electrical force to be more equal, or at least about the same, the charge of the charge of the tape would have to be around 3.8959 times 10 to the negative 8 coulombs, which is around 257.775% of the original charge found in lab 1. Some assumptions that we had in this lab were that we disregarded air resistance. We assumed that both tapes had the same charge. We assumed that charge was evenly distributed, that the U tapes can be divided into segments of equal charge, as well as that the total charge on the U tapes is the sum of charges of those segments. So here's the computational model from lab 1 and the results from lab 1, including the length of the tape, the width of the tape, the distance between the 2 tapes when they started to repel one another, the mass, as well as the charge that we originally found. Here in our lab 2 code, we have our constants as well as the data from our lab 1 and how we adjusted our charge. So we found the original charge. Here's the original charge. We found the difference between lab 1 and lab 2 results, and then we used that difference to find the new Q. So here's the electrical field function, as well as the function used for the line charge. This actually illustrated the line charge as well in the computational model. Here's where we called our objects, so the top tape, the bottom tape, as well as here is our scaling. And here's our nested for loop that we used for superposition. So this sums all the charges of the different segments of the tape. Here's the computational model produced by lab 2. So we found that that Q is equal to 3.8959 times 10 to the negative 8 coulombs. And when it is equal to this, the magnitude of the electric force is equal to that of the gravitational force, which is around 257.775% of the value of Q determined in lab 1. What if you had modeled each of these tapes as a single point charge, like in the previous lab, compared these values to one another? So for the original lab, if you had looked at it as a point charge, it would have been around 1.51 times 10 to the negative 8 coulombs for the charge. But if you looked at it in this lab, we found that the estimated charge for the line charge would have been 3.8959 10 to the negative 8 coulombs, which this is well over double of the original charge, being around 257.775% of the original charge. Why do these differ so much, and which one is more accurate? So the difference between these two is that, well, first off, the models are calculating charge very differently, as well as since the line charge is accounting for the entirety of the tape instead of looking at it as a point charge. So since the line charge model accounts for the entirety of the tape instead of looking at it as a point charge, adding the charges of the different segments of using the law of superposition, and since its magnitude of the electrical force is closer to the magnitude of the gravitational force in this model, it is most likely that the line charge model is more accurate than the point charge model. So some conclusions were that the line charge model was more accurate, but harder to calculate due to smaller steps, especially with superposition, and that we used Coulomb's law to estimate the electrical field and force. Some potential error here was that air resistance wasn't accounted for, nor were any other external forces. Charge may not have been evenly distributed on the surface of the tapes, and charge may have been inaccurate and calculated inaccurately due to excessive handling in lab 1 of the tapes, and that there might have been some calculation errors. That is all. Thank you.